I didn't introduce myself earlier on. I'm a technical consultant with Uniper, working at their technology centre near Nottingham, England. I provide support to the UK power industry in relation to continuous emissions monitoring, emissions reporting and compliance issues. And that includes the development of guidance for reporting under the EU emissions trading system. Before joining Uniper, I was a gas turbine combustion engineer with Alstom for 6 years. And prior to that, I worked on various aspects of combustion and environmental science with British Gas. I'm a past chair of the UK Source Testing Association and the VGB Technical Group Emissions Monitoring. And by background, I'm a chemical engineer and a fellow of the Institution of Chemical Engineers. So I've already mentioned that I'll be talking about quality assurance issues associated with measuring low pollutant concentrations as per the programme. I've mentioned that I work for Uniper. We're an international energy company with approximately 12,000 employees. You can see how they're distributed at the bottom there. We have power generation plants, trading activities and service provision within our portfolio. We've been around for about 5 years, having been formed as a demerger from E.ON. You can see our activities there and graphically at the bottom. We've got about 35 gigawatts of generating capacity, so gas-fired plants, coal-fired, but also hydroelectric and nuclear. A lot of gas infrastructure, and looking to the future growth areas are hydrogen and renewables. And in terms of our services, we've historically offered services across all disciplines and through the whole life cycle of a plant, from first specification to decommissioning. Obviously, this morning I'm talking more about environmental assessment. So some of this has been covered by Rod in terms of falling emission limit values. So the IED is the principal European regulation. Is given the background on BREFs. I'll just point out the large combustion plant BREF. The back conclusions for that were published in August 2017. There's a 4-year implementation window. So compliance is by this August for existing plant. And BAT-associated emission levels, BAT AELs, are defined as concentration ranges. So for a new combined cycle gas turbine, for example, the range is 10 to 30 milligram per meter cube NOx and 5 to 30 milligram per meter cube CO. So these are significantly lower than previously. Regulators set emission limit values from within that range in a given permit, and obviously depending on whether set it at 10 or 30 has a huge impact on the control technology that's required and also the monitoring requirements. And as Rod's pointed out, monitoring ever lower concentrations presents a number of difficulties in relation to specifying and calibrating SEMs. In terms of the confidence interval that's specified in the IED, that's an allowance for the expanded measurement uncertainty, 95% confidence. So for example, 20% for NOx, and that of the daily ELV, that gives the maximum permissible uncertainty that we have to meet overall for the monitoring. The LCP BREF also introduces a wider range of pollutants for large combustion plants, more aligned with energy from waste regulation now. We've got the traditional pollutants at the top left there, NOx, CO, SO2, dust. And to that, for certain fuel types, are added HCl and HF, acid gases, mercury. And for plants fitted with SCR or SNCR NOx abatement, it's also ammonia and SO3 as a periodic measurement. So most of these are measured continuously under certain circumstances for certain fuels. The main quality assurance standard is EN 14181. Automated measuring system equals SEM, if you're not familiar with that term. It defines 3 quality assurance levels, qual 1, 2 and 3, and an annual surveillance test or AST. QA is based on the daily ELV, which is referred to as the short-term ELV, confusingly. You can see that set up graphically here. So the operator needs to install compliant equipment. This requires type-approved equipment. An accredited test laboratory needs to come to site to calibrate the SEMS every 3 or 5 years. There's an annual check of that calibration, the AST, which again involves the test laboratory coming to site. And then there's ongoing QA checks performed by the operator on a regular basis, say weekly, zero and span checks. So that standard is supplemented by a few other standards in relation to dust, stack flow rate, and mercury. Qual 1 is relating to the suitability and location of the SEMS. So it requires an assessment of the suitability of the SEMS. New analyzers must be certified with a suitable range under EN 15267 Part 3. And that certification is based on testing 2 duplicate instruments in the laboratory and also in the field. The certification range must be less than 2.5 times the daily limit for a large combustion plant and less than 1.5 times for energy from waste plant. And additionally, as Rod mentioned, the measurement uncertainty at certification must be less than 3/4 of the confidence interval. So for NOx with a confidence interval of 20%, at certification, the instrument must be better than 15% of the daily ELV. But of course, measurement uncertainty on a certificate may be less than or better than that minimum requirement. Field testing should ideally be on the same process as the process to which the SEMS is applied. But ultimately, the plant operator is responsible for selecting suitable AMS or SEMS. So what are the issues linked to lowering emission limit values? Well, first of all, can the AMS meet the BAT-AL ranges? This is an example for mercury. So you can see on the y-axis 3 different principles of mercury analysis, fluorescence, absorption, and so on. And then the purple dots are the measurement, the expanded uncertainty from the certificate in each case in microgram per meter cubed. And then the vertical lines represent the BAT-AL ranges. So for coal, for example, the range is from 1 to 4 microgram per meter cubed for existing plant. You can see in the box that the confidence interval for mercury is 40%. So the certification uncertainty, 3/4 of that, must be better than 30% of the ELV. So taking this example of 4 microgram per meter cubed, we need to be better than 1.2. And you can see that there are 3 instruments that can do that. If you look at the certification range, that drops down to 2 instruments. When we go to the lower end of the range, 1 microgram per meter cubed, the uncertainty requirement becomes 0.3 microgram per meter cubed, and only 1 instrument is fit for purpose from that point of view. So, as a general point, AMS may not be available for the minimum BAT-AL concentrations, and to that extent, I suppose you could say regulation is divorced from standards and certification, because we may have a limit value imposed, which we effectively can't measure against with the required uncertainty. The pushback from the Commission on that would no doubt be that you've got to start somewhere, and the technology should catch up in time. But for operators, that does leave some practical issues, and for regulators for that matter. Looking at a similar plot for CO, different technology types, you can see there's a wide range of uncertainty for non-dispersive infrared analyzers, perhaps not surprisingly. They've been around for a long time. Again, the BAT-AL concentrations 5 and 30 milligram per meter cubed in this case are overlaid on there. But in this case, for CO, the confidence interval is only 10%. So we need to be less than 7.5% of the daily ELV from a certification point of view. And for the higher BAT-AL, that takes it down to about 2.25 milligram per meter cubed. So there might be, I don't think there are any instruments that can do that. Certainly by the time you get down to 5, none of the instruments can meet that. So CO is also difficult because although it's almost zero during normal operation, it's very high during startup. So there's a wide measurement range requirement. So issues linked to low ELVs. What happens when the multiply rule is not met, which is a requirement of the standard, but the uncertainty is still okay on the certificate? Sometimes there's a bit of a disconnect between the certification range and the absolute uncertainty. Well, it seems obvious that you would allow the AMS to be used if it has a good enough uncertainty, but that isn't what the standard says. Both of the examples I've just shown for mercury and CO, the BAT ALs are annual, on an annual average basis. So of course, in principle, you could just set higher daily limits to get around the quality assurance problem, but actually that isn't a solution, because you might end up buying an analyzer that's good for a high daily ELV, but it's not fit for purpose for measuring emissions most of the time across the year. By definition, the plant has to run below the annual ELV for most of the time. So to my mind, it makes much more sense to use the lowest emission limit value for assessment. CO is a particular issue. Many member states have allowed an increase in the confidence interval for quality assurance assessment to 20%. But more generally, what happens when Qual 1 requirements cannot be met by any AMS? Well, we could relax the relative uncertainty requirement. That's difficult since it's specified by regulation. Or as Rod mentioned, perhaps the way forward is absolute uncertainty thresholds for each pollutant. The general problem is how to make the certification process more flexible and responsive to change. And I will just mention that obviously when you're taking a single sample from a measurement plane, there is some residual concentration variation across that plane. And the original assessment will have been done using an older ELV. Yes, so we take duct surveys under EN 15259 and then assess whether the concentration is homogeneous. So at the very least, if the ELV is reduced, that assessment needs to be repeated. And generally speaking, positional uncertainty is going to become more important. So that is defined in 15259, and we need to reduce that as far as possible or eliminate it if we can. So moving on to Qual 2. This is the straight line calibration between the test method as operated by the accredited laboratory and the plant monitor, the AMS. This is a rather idealized set of results showing almost one-to-one agreement, which is what you would hope for. The valid calibration range is 10% higher than the highest reading. The min-max data range determines which method of analysis is used, but this is simply whether you include all the points in a linear fit or just average them into a single red dot up here and then pass it through zero. And there's no absolute requirement for the SRM to agree with the AMS. The only test is a variability test. So this is looking at the data scatter, and it's the standard deviation of differences between the test measurements and the calibration line. And broadly speaking, for a confidence interval of 20%, that has to be less than about 10% of the daily ELV. However, the test laboratory comes back a year later, performs the AST, and then they must check that the absolute average difference between the new test points and the original calibration line is better than a tolerance, and that again is 10% of the daily ELV. So it's obvious that as the ELV reduces, these tests become harder to pass, but these are actually quite generous, I would say, for the primary pollutants. So probably okay in many cases, but maybe not for trace species, and by trace, I'm just meaning low milligram per meter cubed in this instance. The 2014 revision of the standard allowed the use of reference materials to improve the calibration. Of course, the reference materials have to be of really good quality. So this addresses a situation where you have a low-level data cluster. You can put in a zero and a span point effectively. That's a really good option for CO, because there may not be appreciable levels when you're doing the qual2 measurements, but it doesn't really help with particulate matter, since there are no milligram per meter cube reference standards for particulate. And generally speaking, it's much more difficult for low concentrations of acid gases, such as HCl, where you're close to detection limit. And perhaps the use of method D, which was introduced, or procedure D, introduced in the flow standard, would be useful here, and that just involves forcing the calibration function through zero. That should certainly be considered more, but we're having presentations on particulate and HCl later. In terms of broader issues, well, it would be fair to say that the qual2 calibration using the reference method does mostly deal with the uncertainty associated with the AMS, because it calibrates it out. But SRM uncertainty is therefore of critical importance for determining the transferred uncertainty within the qual2 calibration. 14181 presumes that the SRM is perfect. It doesn't say that, but it's a presumption for zero bias, which clearly can't be true. But it recognizes that an imprecise implementation can result in qual2 failures. So this is saying if the data scatter contribution from the SRM is too high, you'll fail the variability test. It points out that the standard deviation of differences, the variability, contains elements from both the AMS and the SRM. However, it doesn't contain the overall uncertainty of the SRM, and certainly not the systematic components. So it's worrying that that standard deviation is used by some competent authorities as the basis for compliance assessment when it doesn't incorporate the full SRM uncertainty. Conversely, the daughter flow standard does recognize the importance of SRM systematic uncertainty. That was really very much focused on trading applications, and it's obvious that the full SRM uncertainty should be assessed. And as Rod has mentioned, field trial validations for the original standards were at higher concentration ranges, and many of those standards require revalidation at lower concentrations. In the meantime, proficiency testing, where a number of labs measure from the same stack or test rig, that can also provide useful information. And in our view, the IED confidence interval approach to compliance assessment is legally robust, given all the uncertainties and the uncertainty, and it's also simple, provided that the required uncertainties can be met, of course, the 20%, 10%, and so on. And in that situation where they can't be met, something else needs to be done, such as a fixed absolute uncertainty. And I'll just very briefly mention quality assurance level 3. So it's the drift is measured, say, on a weekly basis, plotted on a chart with warning and action limits, and the AMS is allowed to drift within those limits. So if there's a really good zero performance there in the top chart, you can see some drift here in the bottom chart, and around July 2009, in that case, it looks like something was done to the instrument, and that has been corrected. So that's the sort of use of qual3. Why does a lower ELV matter? Well, we need stable reference materials at low concentrations. That's the first point. And also, the control limits are often based on the daily limit value again, the proportion of the daily ELV. So there's a possibility of increased failure rates if the current performance is close to the existing control limits. And of course, that might well be indicating you need new SEMS at that point, new AMS. So I'll just conclude with a brief wrap-up. ELVs are reducing under European BREFs. There are challenges in specifying, calibrating, and controlling AMS at these lower concentrations. In terms of type approval, it's there may not be a suitable AMS available. There's the question of using the annual rather than the daily for quality assurance assessment. The certification process needs to be more flexible and responsive. In terms of calibration, more flexibility is needed for particulate matter and trace species. The SRM uncertainty dominates the calibration uncertainty, and we've talked about the issues there and the importance of having a robust approach for compliance assessment. And finally, I've just finished with Qual 3 there, potential for more failures depending on the existing control chart margins, and the possibility that there may need to be some sort of relaxation of uncertainty targets at low concentrations, and especially for CO. So thank you for your attention. Just checking timescales. I think we have time for one or two questions, 2 or 3 questions maybe, if there are any.